All right, so as you can tell, the first thing we're starting off is what we kind of ended with on the last chapter, which was the inverse. And basically the idea was, hey, if the x value is pi over 2, the inverse pi over 2, the inverse y value is going to be pi over 2. We just flip the signs, right? And that's all we had to do on that. We're kind of doing the same thing here. And the idea is now we're taking everything we've done and we're just kind of flipping it. So it's going to be, hey, what's the inverse sign of square root of 3 over 2? So now the idea is we're giving you the trig function and the x and y value, and you just have to find the angle. So that's the idea. So it's not really, like I said, it's not really inventing a wheel at all. We're not reinventing a wheel at all. We're just kind of figuring out a different part of it. And that's it today, okay? So, and this, it goes with the unit circle for the most part. And from today, you can go in and we can use the square root trick today if you need to use that or whatever to go ahead and get re-established with that. So, first thing we'll look at is let's talk about the inverse trig function and talk about making it one-to-one. We're going to go a little bit more detail of it. You saw the video from last class. Did I show you all the video? I must have showed B days. But anyways, it's just talking about the inverse and what it is. And basically the idea is you can't have an inverse function unless it is considered one-to-one. That is a golden rule stated all the way through. You guys go on to college algebra next year or whenever, that will be brought up again many times as well. You cannot do the inverse of a function unless it is one-to-one. And one-to-one basically means that it passes a horizontal and vertical line test. Well, as you can see, I drew a few lines here. Does this sine function right now pass a horizontal and vertical line test? No. What does it fail? The horizontal line test. So we need to go in and say, okay, well, the whole entire function itself is not going to work. We're going to see that right there. So maybe we can go ahead and restrict it to just certain values. Maybe we can go ahead and cut this graph and just go ahead and narrow it down into one. And this is what you guys did in class. And we can do this and say, okay, if that's the case, well, we know we can go with a vertical line, it'll pass all the time. So that's not the problem. The problem lies in whenever I do this. When I do this. Here and here again. So maybe I can go ahead and restrict it from negative pi over 2 to positive pi over 2. If I do that, and I'm going to go ahead and erase all this off to the side, or just kind of cover it up. What about what remains? Well, look at what remains. Does that pass a horizontal line test now? Yes, we have stopped it from, and we have pi over 2 right here, and negative pi over 2 over here. So if we take this function and only block off that box, we've established a sine function that can have the inverse. Why am I telling you all this? Because of this right here. Your answers will only remain, the answers when you enter these inverse trig functions, pi over 2 is up here. Do y'all agree? Do y'all agree with that? Negative pi over 2 is the same distance except we're going in a different direction. So that means with sine, that looks like chicken scratching. Sorry guys. I'm going to get better at this. Probably not much better, anyways. So the idea is this, guys. If we do inverse sine, guys, all your answers are going to be either in the first or the fourth quadrants. And so we say first or fourth quadrant for sine. That's it. Because remember, guys, when we come up with an answer and you end up finding an answer here, the inverse, you're going to have multiple answers that you can get it. We want to go ahead and narrow it down to negative pi over 2 and pi over 2. What about cosine? Cosine, we're going from 0 to pi. Well, if you look at what quadrants those are, 0 is here, so pi is there. So this is sine, inverse sine. inverse cosine. So your answers for inverse cosine, guys, will be only in the first and second quadrant. What do you notice about the x values in the first quadrant compared to the second quadrant? What the x values from the first quadrant to the second quadrant, what's the difference? Negative. Exactly. So by covering the first and second quadrant, we are covering all of the possible positive x values and all the possible negative x values. Okay? Then you move on to sine to the other side, and if you notice, what's the difference in y values from the first to the fourth quadrant? Exactly, the sign, right? So, we can cover all possible y answers if we just go ahead and include first and fourth quadrants. First quadrant takes care of positive y values. Fourth quadrant takes care of negative y values. All right, guys? And that's how that all works there. So if we go through all this, which I am most likely going to skip through all this. Oh, actually, you know what? This is going to help us out find some more problems. So this is what we'll do. We will fill out these tables. So in which intervals are sine and cosine considered to be 1 to 1? Interval from negative, we're including it, pi over 2 to positive pi over 2. And in cosine, we said from 0 pi to pi. I don't have a lot of space to write this stuff in. All right. So this table, guys, will probably be your reference for a while, just to help you figure out this inverse situation. So we're going to go and go through this and say, okay, what are all the possible, we use radians, what are all the possible radians from in the first and fourth quadrants of sine? So with sine, we go through and say, okay, we have 0, of course, we have pi over 3, nope, pi over 6. We have pi over 4. We have pi over 3 now. We have pi over 2. That covers first quadrant, right? 0, pi over 6, pi over 4, pi over 3, pi over 2, right? First quadrant covered. Now let's go ahead and cover the fourth quadrant. This way down. We've already done 0. We've already taken care of that. Now we got to take care of these last, well, it says 3, but we'll go ahead and get to the third one. So from here, we go ahead and figure out, okay, from the fourth quadrant, if you're looking at the fourth quadrant, what's the first one we see here? Well, it is 60 degrees from the 360. So the reference angle is 60 degrees. So what's the radians of 60 degrees? Pi over 3, but we're in the fourth quadrant. So what's pi over 3 in the fourth quadrant? Johnny, do you remember? No way, he says. How about double the denominator and subtract 1? There you go. There you go. Now we have pi over 4 in the fourth quadrant. Double the denominator and subtract 1. What do we have now? There you go. Pi over 6. Double and subtract 1. All right, Johnny's on a roll now. So, quadrant 1, quadrant 4, y-axis, x-axis, I have to do one more because no I don't. It's fine. It's fine. Alright, so let's go ahead now and let's go through the sine value of all of these. And whether you use the square root, and here's what I'll do today, guys. So it's up here. Right, what is the sine of 0 degrees, guys? 0. Good. So I have sine of pi over 6. Sine of pi over 6. Close. Over 2. 1/2. Sine of pi over 4. Next one. Very good. At the very top of the unit circle, guys. We're at the very top of it now. Pi over 2 puts us at the top. What is the sine of pi over 2? I heard 1, I think. Was it 1? There we go. First quadrant's done, including the axes. Now let's go ahead. The good thing about this, guys, is you see pi over 6? When we get to this one here, what do you notice the denominator is? 6. So it has the same reference angle as pi over 6, which means it's going to have the same value. However, what's going to be different? It's in quadrant 4, which means that this value, y values, are negative. There you go. So I'm just going to go ahead and copy what pi over 6 is, and I'll put a negative in front of it. Because they have the same reference angle. Pi over 4, same answer as before, just a negative in front. Because they all share the same reference angle, guys. Same thing for 5 pi over 3. All right? And that's stuff we did back before we did graphing. Just unit circle stuff is all that was, just to refresh there. All right, going over to the other side of the table. Again, going through the values, 0, pi over 6, pi over 4, 3, 2. I go through 11 pi over 6. Whoa. 7 pi over 4, and then finally 5 pi over 3. Whoa. Sorry, guys. What do we say we have to do with cosine? What are we restricted to? What is the interval above it say? 0 to pi. I accidentally went pi over 2 and negative pi over 2, right? So basically I have, this is first quadrant, and now taking you over to pi is the second quadrant. So let's take these reference angles, as pi over 6, pi over 4, and pi over 3, and let's put them in the second quadrant, which will give you a hint, is denominator minus 1. So we go back to pi over 6. What's the denominator minus 1? The reference angle of pi over 4 and the second quadrant is what? It's just taking the denominator and subtracting 1. All right, we filled out all the angles for it. Now let's go ahead and figure out the values. So cosine of 0, if you look on the square root trick, is going to be what? Cosine's here, right? Which is the bottom number. Square root of 4 over 2. 1. Pi over 6. There you go. Pi over 4. Pi over 3. At the very top of the unit circle, what is the x value at the very top of the unit circle? That'd be the y value. That's all right. All right, so now when we go into the second quadrant, guys, you've already done the hard work. You already know the values of it. Now you just need to change the signs of them, right? So with 5 pi over 6, the reference angle is what? Pi over 6. So what is the value at pi over 6? And now you just go ahead and turn it and change it to negative. Bless you. Same goes true all the way down. Same is true all the way down. All right, so the hard work is done, guys. And like I said, this table, which won't be given to you all the time, this will just help you get started. So now it goes on to ask instructions like, find the exact value of the inverse sine of 1. So what you're going to do is, and like we just did on the test, all of your x values are your y values and vice versa. So all we do now is, okay, inverse sine. Well, when you found this, you said the sine of pi over 2 is 1. The sine of pi over 2 is equal to 1. Now it wants to know what's the inverse sine of 1. Sine of pi over 2 equals 1. With that being known, what is the inverse of 1? Which means the sine of what angle is going to give me the answer 1? You go to your table, second column, the sine table, second column, and look for 1. Where do you see 1? What is the corresponding angle to that number 1? So with sine of 1, you see this here, which I just pretty much covered it up, but you get the idea. It should be a highlighter. But there's 1. It wants to know what is the x value that gives us that. Here's 1, and that's your answer right there. Okay, and it goes on to say, find the exact value of the inverse sine of the sine of 5 pi over 8. Let me do something off to the side real quick. What does that end up being? Why? These cancel out. Square root and squaring are inverse functions, which means they cancel out each other. Why do you think I'm telling you that right now? There's your answer. Find the inverse sine of sine cancels out the sine. That sounds really badly worded, but that's exactly what it is. Finding the inverse of that same function gets rid of it. Same is true as the inverse of plus is minus. Same inverse of minus is plus. Inverse of cubing is cube root. I mean, all this stuff comes together because, guys, you can write x squared. Another way of writing the square root of x, guys, is also writing it x to the negative 2. Look at those two exponents. You see how it's the negative of the other? And if I was to go back and put an exponent to this sign, it'd be to the first power. And look how both of those are negative to each other. Do you see that? Which means they cancel out each other. So your answer ends up being 5 pi over 8. Let's move over to the cosine. What is the inverse cosine of negative pi over 2? Oops. So, negative pi over 2 is located right there. What is the degree that gives us that value? That's right. I'm going to get my colors right. That'd be great. And of course, you see the same thing here that we talked about earlier. The inverses cancel out each other. And there's your answer. We good? Somewhat, as can be. All right, so a few things just to see on that box there. The inverse sine of, and it's probably what we talked about, it's just a mathematical saying. And guys, it doesn't have to be the inverse sine first, it could be the inverse sine second. So the sine of the inverse sine of something gets rid of it. The inverse cosine of sine also gets rid of it. So just know the inverses of each other, guys, gets rid of them, okay? All the way through. All right. So let's talk about inverse tangent real quick. And we say, okay, what do we consider an inverse tangent interval? Well, we'll do the same thing. This will be a little bit easier to see. However, if you notice, if we go in between asymptotes, include them, so we're going from, again, negative pi over 2 to positive pi over 2. Which interval is tangent theta considered to be 1 to 1? Which tells you all the inverse tangent functions will be in the first and fourth quadrant. And so tangent, as we said over here, is if you divide those two together, right? So finding the inverse tangent is a little bit trickier for the most part, because sometimes you see values that doesn't look familiar. And there'd be different versions of it. So we're looking here at negative root 3. Well, if we come over here, and you can rewrite this as a fraction. And I encourage you to do that in tangent. Tangent is sine over sine, or cosine. Sine over cosine. So which one of these angles is going to give me the square root of 3 over 1? Yep. You see that? Square root of 3 over the square root of 1, which is 1. Which ends up being just the square root of 3. So we end up getting pi over 3 is the answer. However, it is negative. Pi over 3 is located in what quadrant, guys? Yep, here. Well, we need it to be a negative answer. And remember, guys, we can only use the first or the fourth quadrant. Well, guess what? The first quadrant is not going to give us the answer we need. So what do you think we need to do to this fraction here? We need to put it in the fourth quadrant. How do you put reference angles in the fourth quadrant? What's the trick? Denominator times 2 minus 1. So your answer ends up being now it goes on and says, find the exact value of the inverse tangent of 1. Well, what has to be true about a fraction in order for it to equal 1? What? Has to be the same numbers on top as they are on bottom. Which one of these angles is going to give us the same numbers on top as it is on bottom? Or pi over 4? 45 or pi over 4. So, and now we just need to know, does it need to be in the first or fourth quadrants? Well, it's a positive 1, which means that both my fractions has to have the same sign. Both the top and bottom, both 2's have to have the same sign. Or both the x and y values have to have the same sign. Well, in quadrant 1 or quadrant 4, where is it that both the x and y values have the same sign? So, in quadrant 1, that just remains the answer. So the answer is pi over 4. So there's 2 parts to solving these equations. First part is finding the value of it. Second part is putting it into the correct quadrants. The good thing is you have always an option of 1 or 2. One or the other, okay? So you have a choice of 2. All right. And here's some problems. So we're going to work on some even problems. Let me see if I can, I don't know if I can do this on here. It might not be much room. So the inverse cosine of 1. So which one of these, 0, pi over 6, pi over 4, pi over 3, or pi over 2, is going to give us the answer 1? Or you can use your table that you filled out earlier. Yeah, you bet. All right, it'll be a chance for somebody else to answer now. 0. Good, Duke. Because the cosine of 0 equals 1, your answer is 0. Is it getting a little... I know, I don't know what's going on. See, the cosine's there and the one value's there. All right? Now let's talk about the inverse cosine of negative 1. So you can write it like this. Where on a unit circle, guys, of course we are talking about cosine, we're talking about 0 to pi. So where in the first and second quadrants is cosine equal to negative 1? Cosine does with what values, guys? X values. Where is the x value negative? The first or second quadrant? Thank you. Okay, so we're in the second quadrant. We are on this side of the unit circle, right? And what the value is 1, which is the highest value that x can be. So what is the farthest left? What is that angle to the farthest left of the unit circle? It's 180, or how do we write that in radians? And there's your answer. All right. So then we go over to number 18. I want to do it in that color. There you are. Tangent of what angle gives me negative 1? Well, what I like to do here for tangent, since it always is a little bit different monster, I like to just go ahead for now, ignore the sign. Because the sign's just going to tell you what quadrant it needs to be in. It's not going to determine the full value of it. It's just going to tell you what quadrant you're in. So I'm just going to go ahead and say, what's the inverse tangent of 1, guys? Pi over 4. Why'd you pick pi over 4? Why did you pick that one, though? It's the same thing on top as it is on bottom. Good, that's what I wanted you to say. Pi over 4 is the same number on top as on bottom. That's why tangent's equal to 1. Remember, tangent is those sine and cosine divided by each other. In order to get 1, you have to divide 1 over the other. So in order to get 1, it has to be the same on top and same as on bottom. All right, let's address the last thing, which is it's negative 1. Remember, tangent is from negative pi over 2 to positive pi over 2, which is the first and fourth quadrants. In order for tangents, in order for this value to be negative, what has to be true about one of these? If a fraction is negative, what does that tell you about one of the parts of the fraction? One of them is negative. Their signs are different, right? Think about it. If I have a negative 1/3, that means it's either negative 1 over positive 3 or positive 1 over negative 3, right? That still gives you negative third both ways. So why I say that is because I need one of these to be negative, because my inverse tangent is negative 1. So in the first or fourth quadrant, where is the two signs different? Where is x and y different? First or fourth quadrant? Fourth quadrant. The signs are different in the fourth quadrant. So that means pi over 4 needs to be in the fourth quadrant. So how do I put pi over 4 in the fourth quadrant, guys? Say it. 7 pi over 4. It's hard to see, sorry. I'm trying to really make this work in here. But it's pi over 4 in the fourth quadrant. Again, we're asked to find the value first, 1. How do you make tangent equal to 1? Just like Mason said, where both the values are exactly the same, which is pi over 4. So pi over 4 takes care of 1. Then we got to figure out, well, how do we make it negative? Well, the good thing is tangent is only restricted to the first or fourth quadrant. That's it. Well, if the signs are the same, which is in the first quadrant, the tangent's going to be positive. Your tangent's always positive in the first quadrant because both the signs are the same. X and y are both the same. Then we discovered, hey, in the fourth quadrant, what value is negative? In the fourth quadrant, y values are negative, and what's positive? X is positive because you're in that bottom left, right? Bottom left. So with that being said, guys, or bottom right, I'm getting mixed up talking to you airways. But with that being said, that means that all your tangent values are negative in the fourth quadrant. It goes back to this. And I didn't draw this very much because I'm not a big fan of it, but some people need it. The whole idea of the acronym, all students take classes. What that tells you is what quadrants those trig functions are positive. The first one, all trig functions are positive in the first quadrant. Sine is positive, and the only one that's positive in the second quadrant. Tangent is the only one that's positive in the third quadrant. Dylan, you good? Okay. Earphones on, head down means you completely just tapped out. Tapped out too soon. Right? It's like a McGregor fight. Only lasts 40 seconds. So, here you go. So what you see here is, with that being said there, now you can go and say, okay, I have narrowed it down to first and fourth quadrant because we are talking about tangents. Then we go on to say, I need -1, which means I need my answer to be negative. Well, if you look in the first and fourth quadrant, the first quadrant, all trig functions are positive. Well, I need the answer to be negative. So that means that my answer needs to be in the fourth quadrant. And I'm going to go ahead and write these down for you guys too, because I think you'll need it. Well, if that's the case, how do I write a radian in the fourth quadrant? Well, you take your denominator, you double it, and subtract 1. How about in the second quadrant? You take your denominator and just subtract 1. What about in the third quadrant? You take your denominator and add 1. I don't need to write anything in the first quadrant because they're just pi over 2, pi over 3, pi over 4, pi over 6. That's it. All right. Let's move on. So we have the inverse tangent of square root of 3 over 3. This is why I don't like tangent, guys. Because of this problem right here. You've got to figure out what trig function gives you the square root of 3 over 3. I need a square root of 3 on top, but then right below it, I need square root of 3 here. Or positive 3, sorry. Is that happening here? No, it's not. So what needs to happen is, well, maybe they've done something here to this problem to rationalize it. What is an irrational function? It's geometry, you don't remember too much. What does irrational mean? We're actually asked to find this, guys. One over the square root of 3 is an irrational function. You learned in geometry, teacher went over in geometry, how to rationalize it. Times top and bottom by the square root of 3 and simplified, right? What the question is giving you in number 20, guys, is the correct way of writing it. You have to undo it. The reason why you have to undo it is because now, if I see 1 over the square root of 3, 1 over the square root of 3, I'm talking about pi over 6. That's the angle. You can't see it when it's rationalized. And now just settle what quadrant are we in? Well, the question is positive. So are we in the first or fourth quadrant? Good. All right, something a little bit easier. Tangents are hard, guys. Not gonna lie. You've already done 3 problems with tangent. Inverse sine. So we go through and say, okay, using your table if you like, where is sine square root of 3 over 2? I have pi over 3. You even went to the negative, didn't you? You took care of the negative as well. Because as you can see in your table, negative square root of 3 over 2, if you look at your table, move over to the left and you see 5 pi over 3. All right. Look at your table. Where is sine negative root 2 over 2? Good. You're not going to have a table. This is the day 1 of it. I'm introducing you to it. So I want you to be able to at least see what we're finding here. Okay? So what I want you to do with your partner, guys, which is person to your left or person behind you, I don't care. Someone that's close. I want you to go ahead and work 13, 17. Nope. I don't want you to do more tangents. I want you to work 15, 19, and 23. 15, 19, and 23 on your own and see how you do. You good, Mackenzie? One has pi over 2. 15, 19, and 23. This column right here.
That's from the unit. Like if we were to go back and do the unit circles, if we were to go back and look at it, and that's what these are. See, 5 over 6. 5 over 6 is here, and it says the sign, which is the top one. So square root of 1, which is 1. 5 over 4. Okay. Well, that's why you can use this. Look, I don't want you to memorize the unit circle. No way. That's not happening. You can either use the square root or you can use it. So like.
So it'd be this one. Plus 1. Okay, so pi over 2.
Square root of 2 is the sign.
If it's in this quadrant,